Okay, so this is an AP problem here. The R is a region bounded by the x-axis in the graphs of y equals 5 minus x and log x. So there's our linear function, there's our log function. We want to know where those two functions intersect. And the cross sections are perpendicular to the x-axis, so we're going to have these sections perpendicular. This length is going to generate a square, okay, and those squares make the 3D object. Right, but do not evaluate the integral. Okay, so I first of all need to figure out where those two lines intersect. So we can't actually solve this equation, log x equals 5 minus x. Okay, so that A there, this must be a calculator section because from a calculator problem, because we need to actually calculate that intersection point, solving this equation here. Okay, so I'm just going to solve that equation by graphing those two functions and find out where they intersect. So I get log x, okay, and I'm just going to do it as minus 5 plus x and see where that crosses the x-axis. So this takes me a second here on my calculator. Okay, I'm getting a value of 3.69. Okay, so x is equal to 3.69, and we need to use a graphing tool to do this. Okay, because you cannot solve that algebraically. So that's 3.69. So what we want then is we want the squares generated here. So I'm going to make that region red. Okay, so the volume that's going to be generated by those squares there are going to be from 1 to 3.69. It's going to be the log function. The height of that log function here will generate the squares. So squared plus, we want the integral, and I'll do this in blue, the integral from 3.69. Okay, that's going to cross the x-axis at 5. Okay, so 3.69 to 5, and we want to square that height, that linear function squared. So that's going to be the squares generated from there. Those perpendicular, those cross sections, the length perpendicular to x-axis, making cross sections, those will give us our square pieces. Okay, and then we're going to give thickness dx. Forgot to give this one thickness dx. Okay, and then that would then represent the volume of that solid made from those two functions. Just clean that up a bit. It should be plus here. Okay, so those are going to be the solid. The red represents the integral that generates the solid here. The blue represents the integral that makes the solid here.